Hello everyone, welcome back to the Foundation Engineering class. We are going to continue the class with next step. This is still on the settlement of shallow foundation. Today we are going to discuss 2 points: primary consolidation, the settlement relationship, and a three-dimensional effect on primary consolidation settlement. Okay, we are going to discover this these 2 points today. The first one, primary consolidation settlement relationship. I think this is just a reminder because we did everything already in the chapter 1. Okay, so I recommend you go back and check what we did in chapter 1 because I'm not coming back on everything we did there. Okay, so this we did mention before at the beginning of this chapter that consolidation settlement occurs over time in saturated clay because in clay the water cannot escape easily like in sand. So it takes sometimes years before all the water can be expelled from the clay. Okay, so if you consider something like that, this kind of configuration, you have your footing here, and this is, for example, sand layer. This porous material, and you can see the water level here, water table. The groundwater table is here. Okay, and you have here clay, which is obviously saturated because the groundwater is here. So this clay, when you push and you load this foundation, it take time before the settlement of this clay layer can be completed because it contain water, saturated clay. Yeah. So the thickness of this clay can play a significant role in the settlement. Okay. And also the stress level, as you know, when you load uh, when you load on the ground, immediately at the base of the foundation, you have increase of stress. Okay, the effective stress will increase. And when you go deeper, the effect of the loading will decrease like this. Okay, but of course, before even loading, you have some stress, right? The self weight of the soil itself. And when you increase when you add load on the soil, then you will have several possibilities. But anyway, we are going to see how all these can affect the settlement of this clay layer. But as I said, it's just a reminder because we did it before. So what we did it was based on the one-dimensional consolidation settlement, okay, in chapter 1 of this program. And it was about this, okay. SC, primary consolidation settlement, and delta E is the change, okay, the change in the void ratio caused by the additional load you are applying on here. Yeah, and the initial void ratio also is considered. Initial void ratio is 0. Okay, so how do we obtain the change in the void ratio, okay, due to the additional load? So of course you have to do this for each clay layer. If you have only one clay layer, then okay. And also you have to do it normally for all the depths, the thickness. That's why what you are seeing here, it's just a vertical strain, this vertical strain, because it's like it change in dimension. The change in void ratio is related to the change in the thickness, the the thickness of the clay. Okay, so if you do that, integrate this for all depths, you will get then the total primary consolidation. Yeah. So here are the equation, if you remember, we did in the chapter 1. Okay. We have we have 3 equations depending on the situation we are facing, depending on the consolidation state. If it is normally consolidated or over consolidated. Okay. The consolidation ratio, over consolidation ratio of your clay will also affect the settlement. Okay. So you have more parameters. So what you see here, sigma 0 prime is average effective pressure on the clay layer. That is before construction. Yeah. Before building anything. So sigma 0, it's like a self weight of the soil or something like that. Okay. And here the sigma delta sigma average, this one is actually the increase of the load you are bringing. Okay. Load you are bringing to add here. So that means increase in effective pressure on the clay layer caused by the construction of the foundation. Additional stress. Okay. And this sigma C prime is reconsolidation pressure. That's why I say you have to go to maybe soil mechanics 1 and or chapter 1 of this program. We have shown some graphs that can give you the definition of this reconsolidation pressure. Yeah. For H, this is initial void ratio. This is compression index. Compression index also, we did it in the chapter 1. Or go back in the soil mechanics 1, you will see after doing the lab test, the curve can give you the compression index and swelling index also. HC is just the thickness of the clay layer. So let's go back to this equation one by one. This first one is for normally consolidated clay. So it means the consolidation, the pre-consolidation pressure is less than the the pressure you are adding. Okay, normally consolidated. And this one is for over consolidated clay. With a situation where the sigma prime 0, it means here, this one, the initial before plus the additional stress, when you add both, are still less than the pre-consolidation pressure. It means the soil has experienced heavy load before in the past, load higher than all these combined together. Okay, that means your clay is over consolidated. Okay, which is opposite of normally consolidated clay. And here it means the stress that the soil has experienced before is less than what you are bringing. But here it is opposite. Okay. In that case, you use this formula. You can see here the difference. You have here the swelling index. Okay. If you compare this one and this one, you can see the difference will be this index. Okay. Yeah. And here we have the compression index. Here swelling index. And next, the third situation is when you have this kind of configuration. It over consolidated but you have this, the sigma prime 0 is less than the pre-consolidation pressure. But then if you add the additional load due to the foundation to the initial one, then it will be over the pre-consolidation pressure. So you can see that the pre-consolidation pressure is a very important parameter factor, and we have learned this in chapter 1. Please go back in chapter 1 and see the curve from the lab test, how we obtain this pre-consolidation pressure. Okay, so if you are a student, sometimes it's just given to you, but if you are a professional, you have to go and get it. Take some clay sample and go in the lab and perform some tests, and you will get it. Okay, so let's continue. We keep this here like this. Okay, so about now the average increase in pressure. This one, you can see it here. Yeah, because as you know, the increase in pressure, for example, this line, okay, the increase in the stress is not like uniform. It is not like this. So it depending on the position, each position. So the thing is, we have to try to find average value of this. Okay, that's why you can see this one, this kind of thing, and this one. So we will use this. It means the value of the stress increase here at the top of the clay layer, the surface, and then at the middle here, and somewhere around here. We will take these to calculate this average actually. Okay, as I said, sometime if you are a student, sometime like in the class, this is like a given data, you can given information, you can use it, but in practice you have to go and find it by yourself. You have to go and calculate it by yourself. And in soil mechanics 1, we have learned a lot of ways to calculate pressure distribution, effect of pressure, using Business theory method. Okay, so this is how this average increase of in pressure is calculated. Okay, use this one, sigma delta T. So this sigma delta T is sigma delta M and sigma delta B are like effective pressure increase at the top. This one, top, middle, and the bottom here of the clay. Okay, this increase is due to the loading. Please remember that. And if you calculate, if you have them, all of them at each position, the value of these three value here in the middle and here at the bottom, you can calculate the average one. Okay, so yeah, this is what I was saying. The method to determine this pressure, the pressure increase due to the various type of foundation load using Business solution is discussed in soil mechanics 1. Okay, please go back to your soil mechanics class, soil mechanics 1, and you will be able to get this information. This is really because you are supposed to know everything about soil mechanics before you come here. So go back and you will find out, depending on the shape of the foundation, rectangular, circular,